All right, so my plan is that this will be my last video for the assignments for our next test. And that's going to be true unless somebody requests a video on some specific problem or topic. But through this video, you get most of what you see in my math lab assignments and in the book. And at this point, if you've more or less understood the videos I did leading up to this one, you will encounter something called the rational zeros theorem. Okay, and it just gives us a way, I guess you could say, to get this hint. Here's a problem I did in my last video. Solve that big equation, and I give you a hint. And the hint tells you one of the factors. And if you know one of the factors, you divide it out and you get the rest of them. Okay? That's just like the bird's eye view of how we did it. Now, what if you don't have the hint? You need that to get the ball rolling, and if you don't have it, you have to have some way to figure it out. Okay? So there's something called the rational zeros theorem that gives us the possible zeros to a polynomial. Or it could give us the possible solutions to this equation. All right? Now, underline possible. I'm not saying that what I write down and say it's possible, they may work or they might not. That's what the word possible means. Okay? Now, I'm not going to tell you how to do this by a formula or in some abstract way. I'm just going to tell you in the context of this example. Okay? So I see this equation, and here's what the rational zeros theorem tells us the possible answers are. Okay? So let's write down possible solutions. They are going to be either positive or negative. All right, that will be undetermined. Okay. And the way that we decide what the numbers are is we notice that there is a last term. And by last term, I mean if you write them in order, as you always should, from highest power down to the constant term, 3, 2, 1, and then that one doesn't have an x, that's the last term. And then there's this leading term, which has a leading coefficient, or I abbreviate coefficient, okay? So the leading coefficient is 6, the last term is 3. Here's how it works. The possible solutions of this are constructed as follows. Everything down here has to divide 6. Divide evenly. 1 goes into 6. 2 goes into 6. 3 goes into 6. 4 does not. 5 does not. And then 6 divides into 6. Okay? And then the numbers that go up here divide that last term. 1 goes into 3. 2 does not. And then 3 goes into 3. Okay. So that's how we think about it. Now, I have to combine all that to give you like the specific number. So here's what we do. We make the list as follows. Like plus or minus, what's 1 over 1? That's 1. What's 3 over 1? It's 3. Okay. What's 1 over 2? It's a half. What's 3 over 2? 3 over 2. What's 1 over 3? A third. What's 3 over 3? Well, 3 over 3 is 1, but I already have that one on the list. So I'm going to write it again. 1 over 6. And then 3 over 6. Well, 3 over 6 is a half. I already have that on the list. So there's my list about what the possible answers are. 1 could be an answer. Maybe 1 isn't an answer. Okay? Negative 1 could be an answer. Maybe it isn't. We'll have to check and see. But these are just possible solutions. So all of these go into the leading coefficient. These go into the last one. And these are all the ways I could divide them. That big list right there. Okay? All right, so if I was going to just tell you what the possible answers are, that's what I would tell you, okay? All right, now, so that's the rational zeros theorem. That's what it says. If I go to like a question where we actually solve something, okay, then I've given you that same equation right here, okay, same one. And that equation looks like one that we did in a previous video, but it was given a hint. The hint gave us a factor. The factor allowed us to divide and factor the whole thing out into little bitty parts and get all the answers. Okay? Now I don't have the hint. You know, it didn't say, here's a hint, 1 is an answer. All right, it didn't say that. But I do have this list on the other page of the possible answers. All right, now, here's what we got to do. We'll just try the stuff on this list until we find something that works. Okay? That's how it's going to go down. Now, you might say, oh, we're like a half and 3 halves, 1/3. Yeah, I guess, you know, I'm not going to try those first, but if I have to, I will. All right? So let's do this. Let's say we have our possible answers on the other page. So let's do like this. Here's how we might think about it. We might say, what was that very first number on my list? It was +1. And then there's also -1. So let's say, is 1 an answer? Okay? What's another way of saying that? That's like saying, is x minus 1 a factor? Because remember, when we have these types of equations, answers and factors are just two sides of the same coin. How would you tell if x minus 1 was a factor of that? Well, you'd divide it and there'd be no remainder. Okay? So to answer this question, I'm going to set up that I'm dividing by x minus 1 into 6x² minus 17x² minus 4x plus 3. Remember how we do this. Keep track of everything. We say, all right, the significance of those numbers, that this one's x to the third, this one's x², this one's x, that's just a number. That's how they are tied together to that. And what's this say? That 1? It says I'm dividing by x minus 1. Okay? And if there's no remainder, that means it divides perfectly, and that means it's a factor. Let's find out. Let's see. How do you do this? You bring the 6 down. 1 times 6 is 6. Then you add these. You get -11. 1 times -11 is -11. You add these. That's -15. 1 times -15 is -15. You add these. That's -12. So to answer our question, is 1 an answer? Or alternately, is x minus 1 a factor? No, because the remainder is not a 0. It doesn't divide perfectly, so it's not a factor. Okay. All right. Now, so here's the way that we might proceed. We'd say, all right, well, maybe it's -1. Okay, if that doesn't work, maybe it's 3. Maybe it's -3. And ultimately, we'd have to check the fractions if the whole numbers didn't work. But let's say that we're lazy and we're not going to do the fractions unless we absolutely have to. Okay. So I'm gonna skip around. I think actually 3 works for this one. So I'm gonna skip around, and you know, you can do it. Pick the numbers however you want to. You can roll dice. Whatever. So I'm gonna go to the next part and I'm gonna say, is 3 an answer? Let's say I have a hunch that I think actually 3 is an answer to that. And the other side of the coin is like that x minus 3 is a factor, right? Because factors come from the answers and vice versa. So how would you set it up to see if x minus 3 were to divide that? You would put a 3 here. We would draw a line. We're dividing into 6x³ minus 17x². So just like up there, we'd say 6 minus 17 minus 4 and 3. Okay, and the procedure would go like this. The 6 would come down here. 3 times 6 is 18. Add those, I'll get 1. I'll get 3. I'll get -1. I'll get -3. And I'll get 0. So is 3 an answer to that? Or is x minus 3 a factor? Then yes. And we're excited. As far as doing math goes, we get excited. We figured it out, okay? All right, now that's a factor of this. What's the rest of it? Well, you divided it. That's the rest of it. What's the 6 and the 1 and the -1 do? Well, that was x to the third at top, so it's 6x squared plus x minus 1, okay? All right, so here's what we now have. The fact that I figured out that 3 is an answer and that x minus 3 is a factor. Now I've reduced that problem I'm trying to solve to this. It says x minus 3 times 6x squared plus x minus 1 is 0. Okay? All right. There we go. Now, to get the other answers, I got to break this down into the smallest absolute parts that I can. And so, how do we do this in other problems and other videos that we saw? Let's see. I factored that. I know I've told you this already. But if we need to make a video about factoring, then we can. Okay? So anyway, I think you factor 6x squared plus x, so 3x and 2x is 6x squared. And I'll try to think of ways you could combine it to get an x and a minus 1. So I can say plus, and I think that'll do it. So 6x squared, 3x minus 2x. Yeah, that's going to work. Okay? And then every one of these factors, being that they're as reduced as possible, gives me an answer. Okay, and you might say, well, that one tells you 3 is an answer. This one tells you 1/3 is an answer. And that one tells you -1/2 is an answer. You might be able to look at it and just do that. But I guess when we do that, here's what we're thinking. We're thinking if you multiply these 3 things together and you get 0, then any one of them could be 0 to make that happen. So really, if we don't take things for granted and we show all of our work, we'll say x minus 3 could be 0. That's one way it could work. Or 3x minus 1 could be 0. That's another way it could work. Or 2x plus 1 could be 0. That's the last way it could work. And we solve each of these and we get our final answer. So the final answer is that 3 is a solution. Say you solve that one, 1/3. Say you solve this one, -1/2. Okay? And that's all of them. Now I note to you that all of those numbers are on this list because those were the possible solutions. Okay. All right. Now, there we go. That's how you use the rational zeros theorem and a little bit of trial and error. You might call it guessing and checking, or call it whatever you want. All right, but that's how we do it. We need to just find that first answer and then use that answer to factor it and then continue from there. Okay, so that's how it's done. See problems like that on the assignments. Now the next one I want to show you, I think you'll run into one more like this. Okay, I've actually worked it out ahead of time, and on the other videos and the other problems I did, I've been more or less working them out as I go along. For this one, I've actually worked it out because it takes a while to do it. I've actually showed you all the little parts already, and after all, it is a video, so you can pause it. You could watch the video at your own speed, or you could not watch it at all, whatever you want. Okay, so let's say we got this problem. To solve x to the fourth plus 2x to the third minus 5x squared, and so on. This big equation. Now, I would do that the same way I did this other one. I've got to get a list of possible answers and start trying stuff on the list. Okay? So there's the possible answers. What's the leading coefficient? 1. What divides 1? 1's the only number. What's the last term? 4. What divides 4? 1, 2, and 4. Combine all that, you get possible answers plus or minus 1, 2, or 4. Okay? All right, now then we'll go through the trial and error process. We'll say, well, is 1 an answer or is x minus 1 a factor? It turns out no. Is 2 a 0? I mean, you could check -1, but remember, I'm more or less trying to illustrate the fact that you need some trial and error. So I decided to try 2 next. And when I divided by x minus 2, I got 0 for remainder. So yeah, x minus 2 is a 0 of that equation. Or x minus 2 is a factor of the equation. Here's the rest of it. X to the third, 4x squared, 3x minus 2. So then I'd get down to this point. Okay? All right, I was able to find an answer and factor it. The problem is, like, you see that deal right there? That's still too big. I mean, if I'm going to get you the answers, I got to break it down into like smallest parts. So I'll now take that and I'll try to find zeros and factors of it. And the possibilities are no different than the numbers on that list. So here's what I tried. I said, okay, of this thing here, could -2 be a 0? That was another number on the list after all. I tried 2, it worked. Maybe -2. So is -2 is 0. I set up the division. Divide by x plus 2 into x to the third power plus 4x squared plus 3x minus 2. And I divided and I got 0 for remainder, so yes. So now I get x minus 2, and then that breaks apart to be x plus 2 times this, x squared plus 2x minus 1. Okay. All right, now when you get to this point, you'll realize that you can't factor that. If you try, it just doesn't work. So you have to use something called the quadratic formula to extract the answers from that part of it. So you'll get 2 from this one, -2 from this one, and out of that, since we can't factor it, we'll use the quadratic formula. We'll get -1 plus root 2, -1 minus root 2. And those are all the answers. Okay? Now, I wanted to like take a separate slide here and review the quadratic formula. I mean, there's the work. If you know how to do it, that looks familiar. For those of you that don't, I'll just show you how you get the answers out of that separately. Okay? So here goes. Let's call this review of the quadratic formula. The quadratic formula will give us solutions to equations like this. Something times x squared plus something times x plus a constant equals 0. So in other words, if you had x squared plus 2x minus 1, it would give you the answers to that. Or you say, what are the answers? I know the answers I get from these pieces because they're simple, but what do you get out of that one? Quadratic formula will tell you. All right, now, so how can you solve that in general? You can solve it by factoring if you can, but this is the quadratic formula. It always works. So, as it is that I've been factoring, I guess, just to be honest with you, that always works. So every problem like that I have factored, I could just do it that way, and it's always going to work. All right. So some people might have the view that, well, I'm never going to try to factor because that will always work. I just plug the numbers into that formula, and it gives me the answers. Okay, fine. All right, if that's the way you want to do it, I guess for now I don't have a problem with it. Okay. All right. Now let's use the quadratic formula to solve that. And I notice out of this one, it is that type of equation. And I would say that A is 1, B is 2, and C is -1. And those are the inputs into this. And that just gives you the answer. Okay? So here goes the solution. X is equal to All right. So let's do this. It says the opposite of b. What's the opposite of 2? It would be negative 2. That negative right there doesn't mean that that part of it is default negative. It just means we take the opposite of whatever that number is. So I get negative 2 plus or minus square root b squared. What's 2 squared? 4 minus 4 times 1 times negative 1. B squared minus 4 times a times c. So you're looking at it over 2a. So I get like that. Now there is contained my answers to this. Okay. All right. Now, so from here, as with just any problem, I have to do the math. So I get negative 2 plus or minus. I can't do anything with that yet. What's this number? What's negative 4 times, or negative, what's 4 minus 4 times negative 1 times 1? That number is a positive 4. 4 and 4 is 8. So I will get like so. 2 times 1 is 2. And I don't know the square root of 8. Square root of 8, or 8's not a perfect square. But 8, it being that it's not a perfect square, I do realize it's 4 times 2. And 4 is a perfect square. So here's how we reduce it. We say negative 2 plus or minus. This is seen as the square root of 4 individually times the square root of 2. The square root of 4 is 2. And the square root of 2 is, I don't know. I have to leave it like that. The square root of 2 is not some simple number. We would just say root 2. Square root of 4 is 2. Square root of 2, I will just leave it. So we get like this. And then it's seen that both terms up there get divided by that number. So what's negative 2 divided by 2 is negative 1. And what's 2 root 2 divided by 2? Well, again, I get some canceling. And I get root 2. Okay? So in the case that we got a plus or a minus, both terms get divided by that. So okay, what are your answers to this? I get 2 of them. I get negative 1 plus root 2. And what's the other answer? Negative 1 minus root 2. Okay? All right, so for that, all by itself, those are the answers. But that whole procedure, that's how I, saw that and got down here to tell you, well, there's 2 more answers. Okay, so that'll take us through everything that I felt like I needed to tell you before I had the test, but same rules applies with all the assignments and all the videos. You can make requests for anything else.